Assalamu alaikum. Welcome to you all in my YouTube channel Maths Club. This is me Daud Salim. So in today's video I will discuss the vertical line test for a function. Before starting the video I would like you to subscribe my YouTube channel Maths Club. So let us start the video. The vertical line test for function. You must know that not every curve in the coordinate plane be the graph of a function. Yes, this is the reason, like consider this is a coordinate plane. This is x-axis and this one is x-axis and this one is y-axis. So it is written that not every curve in the coordinate plane can be the graph of a function. Let's say that we have a graph like this. This is a graph of function. So a function f have only one value f of x for each x in its domain, and let's say this is point A. Let's say that this is point A. So the Venn diagram of this function will be like this is A. So there is unique f of a for a in the y, whether this is set x or this is the function from x to y. So if you draw a vertical line, let's say that exact on, this is a vertical line exact on a. So then this point, like you can say that this point is said to be a and f of a. You can say that this one point, and this is f of a. Similarly this point, this point is also f of a, because this is the image of a, and this one is also a and f of a. This is a very basic level concept. So but we know that this point, like this point and this point, both are not equal. So f of a and f of a. So here the image for a, this is a single point in x. The image for a is also f of x, f of a, and the image of a is also f of a, but these f of a's are not equal to each other. Let's say that these f of a's are not equal to each other. These are different points in the, as you can see that, and so that's why we study the vertical line test. Vertical line test. So if the vertical line, if we draw a vertical line on the curve of a on the graph of a equation or a function, like as we studied that not every curve in the coordinate plane is a graph of function. So this is a curve. You can say that you can see that this one, like this one is a curve, and we draw vertical line, but the vertical line touches the curve on 2 points. The one point is this and the one point is this, and we saw that let's say that this graph, like the input for a, for the input a, we are getting two outputs. This one output f of a, and the other one is f of a. Let's say this that this is f of a1, this is f of a2, and we are seeing that both are different points. So that is the reason if a vertical line touches a curve more than 1 point, then that is not said to be the graph of a function. So all these stuffs are written over here. Let me explain them again. Not every curve in the coordinate plane can be the graph of function. A function f can have only one value f of x for each. A function, if this is a graph of function, so then for each x a, for each input a, there must be unique value. For example, if we are having this graph, for example, this is the graph. So let's say this is a, point a, and if we draw a vertical line at a, so we are getting only this point f of a a or f of a. So this is the only point we are getting over here. This is, sorry, we have to draw f of a over here. So if we we saw that the vertical line touches the graph on a single point, and we know that if on this graph, on this curve, if we draw the vertical line on any position, we'll get only unique value. So that is the reason, like if you saw a graph, so that graph is not needed to be the graph or the curve of the function, because the value of the function for the function's graph, the value on each input must be unique. So let us consider the example. For example, like this is the example for equation of a circle. As we know that this is the equation of circle, which has the radius 1, like this is 1 unit. For example, the radius between, like this radius is 1. This is center at origin, and this is 1. So if we draw a vertical line, let's say that this is the vertical line, and we know that this line touches the graph on this point and also on this point for point A. So we saw that for point A we are getting this input and this input. So for function this thing is impossible, because in the definition of function we said that, let's say this is A, and as we are seeing that both of them are not equal, you can see that this is in the negative plane and this one is the positive one in the positive quadrant. So we are getting f of a. Let's say that this point is f of a, this point is f of a, f of a. I have to write it over there, but you know there is no empty place, so I am writing it over here. This is f of a, a1, and this is f of a2. This one is f of a2. So we are getting f of a1 and f of a2 for a. This is impossible. So this is not the graph of a function. If we do solve this one for the y, for example, if we shift the x square to this forward, so then this will be 1 minus x square, and if we take a square root, so the value of y will be square root of 1 minus x square. Then the graph will be this one. Then you can say that this is the graph for a function. So if you draw vertical line here, if you draw vertical line here, 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 and here, so we are seeing that we are getting only we are seeing that this vertical line touches the graph on the only single point, so this is said to be the graph of function. Similarly for this one as well, if you draw vertical line here, 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 anywhere in the interval, so we saw that the line touches the graph on the single point. So if, like, the conclusion is that if a vertical line touches a curve on more than one point, then that graph or that curve is said to be not the graph of a function. And similarly, if a vertical line touches a curve on a single or on a unique point, so then that is said to be the graph of function. Okay, so this is all about today's topic. If you have any questions, you may ask in the comment section. Thank you.